sum n equals 1 to infinity minus 1 to the n to the cube over 3 to the n. For absolute convergence. For no, for absolute convergence. Okay, so let me make a remark here. Because the ratio test not only says that the series is convergent, the series is saying it's absolutely convergent. That means this guy is less than infinity. Okay? That's what it's saying. And that's what is so powerful. Okay? So I need to check that that series that I just wrote is absolutely convergent. So you are going to use the ratio test. When it's so weird, best thing to do is use the ratio test. So what I need you to do is find this limit. Limit of n goes to infinity of an plus 1 over an in absolute value. So this guy is your a student. Okay, so go ahead. Let me give you 5 minutes. So I want you to struggle a little bit, but you know that's the way I used to study. I try myself to see how can I approach the problem myself, and then I see what the professor, how the professor is doing. Okay, so go ahead. So let me give you 5 minutes. Okay, just to make sure, so let's do the first part together. So the limit n goes to infinity. What will be an plus 1? What would you put for an plus 1? So if this guy is an, right, what will be an plus 1? What do you guys say? Minus 1 to the what? Minus 1 to the n plus 1. So whatever it says n, I put n plus 1. And then I put n plus 1, what? Cube. And then 3 to the n plus 1. Okay? So wherever it says n plus 1, I replace n by n plus 1. So that's what I'm going to do here. So that's going to be the limit of so go ahead. You keep finding that one, okay? So you have to divide an plus 1 divided by an, okay? I'll let you finish. Okay, so if we replace this value, so we'll get an is the guy on the bottom, minus 1 to the n cubed over 3 to the n. Okay, put it here, an. N plus 1 will be minus 1 n to the n plus 1, and n plus 1 cubed divided by 3 to the n plus 1. Okay, so now the good thing of the absolute value is the absolute value kill all these minus 1 to whatever. So this is going to be limit n goes to infinity, and then we get n plus 1 cubed divided by 3 to the n plus 1 divided by n cubed divided by 3 to the n. Okay, and then we multiply these two guys. So I forget about the actual value because n is positive. 3 to the n is positive. So all those guys are positive. So I forget about the actual value. So we apply the Ear law. Okay. The Ear law means I go n plus 1 cubed times 3 to the n divided by n cubed times 3 to the n plus 1. And now we simplify. Okay. So what can we simplify here, guys? What do you think?
Can we simplify the powers?
Which ones?
The cubes.
Or no? I will take it first the 3 to the n. How can I cancel those 3 to the n? So I can do 3 to the n plus 1 is what? 3 to the n times 3, right or not? We're using this property, e to the n plus 1 equals a to the n times a. That really is a e to the n plus m equals a to the n times a to the m. That's college algebra, right? So with that, I can cancel these two. And now, yeah, we can take care of the cube. So as I said, I'm good with limits. So I'm not scared about limits. So that's something you should, but all these tricks, you just get used to these tricks. So I have these three, I can take this 1/3 outside because it doesn't have n. And I have n plus 1 over n. And I can I can call this guy cube, right? Because it's n plus 1 cube, n cube. Look at this trick. This is a trick that you saw in calculus 1 is continuity. You can do this 1/3 and limit of n goes to infinity, n plus 1 over n cube. This is by continuity of s cube. This is because, you can do that because it's a continuous function. You're taking the cube, you can take it out. And now what is the limit of when n goes to infinity of n plus 1 over n? We did that one before. That one is, what is that? That's going to be limit n goes to infinity 1 plus 1 over n cube. So this guy goes to 0. And the limit of 1 is just 1. So we will get 1/3. So this is less than infinity. Yeah, it's less than 1, not less than infinity. Less than 1. Since the limit is less than 1, by the ratio test, the series is absolutely convergent. Okay, so this series is absolutely convergent by the ratio test because we did the quotient and we find the limit. Okay, so let me give you one to practice. You want to practice. Let's do this one. So I'll leave you this like example, okay? Exercise, and we can finish the class here because I want you to try to do this by yourself. And we'll start next class with that. So study this series, sum n factorial over 100 to the 9, n equals 1 to infinity. So apply the ratio test to decide if series is convergent or divergent, okay? So I'll let you practice this. Let me give you 5 minutes to see how do you do.
Sir, what's next to the n?
Oh, that's n factorial. You guys don't know what is n factorial. N factorial is the following. N factorial is, that means n times n minus 1 times n minus 2 until 1. That means 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1.
Oh, okay.
When I was showing you the function, the function was something like that, gamma n, that's n factorial. But that was for the video. When I was showing you in Wikipedia how the function was defined. But you just need to study this one. Okay, 100 to the n, right? Not times n, but to the n. Okay, let's do it. So we have an is n factorial over 100 to the n. Then we have an plus 1 is n plus 1 factorial over 100 to the n plus 1. And then we make the quotient. Okay, that's limit n goes to infinity. And so we'll put n plus 1 factorial 100 to the n plus 1 over n factorial 100 to the n. Okay, so that's what I wanted to show you the video, because you are gonna see this factorial and you're gonna say that's crazy, right? But it's just real life. Okay, that's how science is showing to us. It's like nature, how nature shows to us. Okay, so it's not my fault. Limit n goes to infinity. And then we go n plus 1 factorial. So I do the ER law, sorry, 100 times to the n divided by n factorial 100 to the n plus 1. And you see, this is, if you're brave enough, you keep going, this start getting easy. Because the 100 and 100 n plus 1 cancel. What do I get then? After you cancel, what do you get?
1 over 100.
Exactly. So this is n plus 1 factorial over n factorial. And this will be 1 times 1 over 100. And now it gets even easier. You might feel scared for this n plus 1 factorial, but let me put it here. N plus 1 factorial over n factorial. What is this? This is n times n minus 1 times n minus 2 times n minus 3, and so on until 1. And here, so n plus 1. And then here n times n minus 1 times n minus 2, and so on until 1. So all these guys cancel. So what do I have left? When I simplify n plus 1 factorial over n factorial.
N plus 1 over n.
No, just n plus 1. Because this n cancels with this n. So this n cancels with this one. So all of them cancel. So I just get limit of n goes to infinity of n plus 1 over 100. And what is the limit? What is the limit of n goes to infinity of n plus 1 over 100? What is the limit?
Infinity.
Infinity, correct. So this is divergent. So by the ratio test, well, sorry, the limit is infinity. By number 2 of the ratio test, if my limit is infinity, then the series is divergent. So this series is divergent. Where did it go? This one. This series is divergent by the ratio test. So we're gonna do more on Tuesday of this. But I already opened the homework, so you can start practicing this. But you can also apply this to any kind of series. As long the limit is not 1, you can decide if it's divergent or convergent. If the limit is 1, well, you have to try a comparison test, a integral test, a limit comparison test, and so on. Okay? So just to show you, we are close to the end, guys. We're really close to finish this. So please don't feel discouraged. We are getting close to finish this semester. Okay. So I'll let you go.
So we're going to office hours today?
Yes, from 4:30 to 6.
Okay.
And sir, the exam 3 is on the 19th?
On the 19th, yes.
Okay. Thanks, sir. Bye, sir. Have a good day.
Goodbye, Kevin.
Have a good day, sir.
Goodbye, Ren.